So last video, we found out this k is 4.3. And then we can write the equation as y equals to 4.3 times x. When x is 12, so 12 times 4, so 12 times 4.3. 3 times 12, that's 36. 2 times 4, that's 8. 1 times 4, that's 4. So I have 6. 8 plus 3, 11. Carry on 1, 5. So 1 decimal place, so 51.6. I think the last video I was too tired. I made a mistake. Last video I calculated 400 something. That's wrong. I was so tired. So when x is 12, y is 51.6. Let's see 41. Is inverse proportion. So inverse proportion, we use the formula y equals to k divided by x. Okay. So this is saying when y is 8, I'm going to change my color. When y is 8, x is 20. So k equals to 8 times 20, 8 times 20, which is 160. So we can write, so k is 160. I'm going to write the equation as y equals to 160 divided by x. And if x is 48, we plug in. So y equals 160 divided by 48. Well, we see common factor of 4. So we divide the numerator by 4. Yeah, 40. We divide the denominator by 4, we get 12. Then we see 4 is a common factor of 40. And 12, we divide by 4, we get 10. We divide by 4, we get 3. So y equals 10 divided by 3. Let's see 42. Inverse proportion, right? So y equals to k divided by x. Y is 14, x is 18. So k equals to 14 multiplied by 18. Well, what's 14 multiplied by 18? 4 times 8, 32. Carry on 3. This one is 10. 1 times 8, 8 plus 3, 11. 1 times 4, 4. 1 times 1, 1. So 252. So k equals to 252. And then y can be written as 252 divided by x. Rational, right? Rational fraction. And when x is 22, so it's just 252 divided by 22. Divided by 22. We get a 1. Well, first we see both even numbers, right? We can keep as a fraction. So this divided by 2, we get 11. This divided by 2, we get a 1, 2, 6. So y equals to 126 divided by 11. Let's see, 43. Negative square root 100. And we know square root 100 is 10. So that's just a negative 10. Here we have negative fifth root of 32. And we know 32 can be written as 2 raised by 5. Right. Then if we do fifth root, so the index is 5. We do fifth root. So when the index and the power are the same, they cancel each other. So it's going to get 2. But we have this negative sign in front, so get negative 2. 45. Cubic root of 125. That's 5. Because 5 raised by 3 is 125. Well, this is negative inside. Negative inside. If this is a real number system, so this is not a real. So it's not a real number, right? Oh, it is a real number because this is a cubic. It's not a square root. So it's a negative 5. So negative 5 raised by 3 is a negative 125. Let's see, 47. The numerator square root will get 10. Denominator square root will get 11. So 10 squared is 100. 11 squared is 121. What is the domain of this function? Which is this inside has to be non-negative. That means negative 6x minus 3 has to be greater than or equal to 0, at least 0. Okay. So we solve for x. We have minus 3 greater than or equal to positive 6x. We move negative 6x to the other side, become positive. We divide by 6, that's x less than or equal to, because if we read from negative 3, that's negative 3 greater than or equal to 6x. But if we read from 6x, that's 6x less than or equal to negative 3. So divided by 6, that's x less than or equal to negative half. So we use a sign less than or equal to, a number is negative half. Let's see, 49. Which of the statements are true given the function of nth root of some function of x? The first one is the domain depends on the value of n. Yes. Right. If n is odd, the domain is all real numbers. If domain is even, then p of x has to be greater than or equal to 0. So this is true. The domain is all real numbers if n is even. No, this is false. Right. The domain is all real numbers. That's false. It depends on n. The domain is all real numbers if n is odd. Yes, this is true. So the first one and the last one are true. 50. So we have a square root of function. Square root of function, this thing, let's evaluate when x equals negative 4. We'll plug in negative 4. Negative 4 plus 6, that's positive 2. So r of negative 4, just square root of 2. No, this is wrong. Negative 4 is in the domain. Right? What about R1? The x equals 1. 1 plus 6, 7. So R of 1 equals to square root of 7. R of negative 7 is not in real numbers. Right? Because negative 7 plus 6, that's a square root of negative 1. Square root of negative 1 in complex equals to I. But in real numbers, it does not exist. R of negative 9, yes, we pick this one. Right? For this question, I'll pick this one. So -7 is not in the domain. And also this one, -9 is not in the domain. R of 0, yes, right? Square root of 0 plus 6 is the square root of 6. R of x plus h, so the square root. X is x plus h now, x plus h plus 6. So 51, so we're finding the domain of all these functions. Square root function, that means the inside has to be greater than or equal to 0. So that's 9x greater than or equal to -6. Divided by 9, that's x greater than or equal to -6 over 9, that's -2 over 3. So we're writing the interval notation is greater than, right? Square root greater than or equal to, starting from -2. Oh, I can't do this. -2 over 3 up to infinity. Yeah, but this is not this parenthesis. This will be bracket. Where can I find the bracket? Yeah. But this side is parenthesis. Oops. Okay, nice. Written as inequality is x greater than or equal to, where I find greater than or equal to, greater than or equal to -2 over 3. Oh, nice. Like this. So similarly, we solve for this one, right? That's -15, -15x plus 12, -15x plus 12 has to be greater than or equal to 0. That's -15 greater than or equal to 0. So we move 12 to the other side, it becomes a negative. Then we divide by -15. We get x. When we divide by negative number, we switch the sign. So that becomes x less than or equal to 12 divided by 15. That's, so we divide by 3. That's 4 over 5. So use the interval notation, we write it as x less than, that means starting from -infinity. Oh, I have parentheses here. Oh no. I choose this one. -infinity. Sometimes it works, sometimes it doesn't work. I don't know. Did I pick this one? Okay, let me. I don't know which one works for this. Scan. No. Select. Last time it worked. I don't know which one I hit. It worked. So let me use this pen. Oh, maybe this one. Let's see. Will this work? No. So it goes from -infinity up to 4 over 5. Because it includes the 4 over 5, so we use a bracket. Okay, so that's this. Let me resolve this. And the set notation is just x less than or equal to 4 over 5. Oh, I can use this now. Negative infinity up to 4 over 5. Then because it includes 4 over 5, so I use a bracket. This one, same thing, 5x plus 1 has to be greater than or equal to 0. So we solve that. That's x has to be greater than or equal to negative 1 over 5. Then up to past infinity. The set notation, that's x greater than or equal to negative 1 over 5. This one's 19 plus 17x has to be greater than or equal to 0, divided by 17 on both sides. That's x has to be greater than or equal to negative 19 over 17. Greater than, that's up to past infinity. Set notation is x greater than or equal to negative 17 over 19. 19 over 17. 19 over 17. Okay, that's for this one. 52. 52 have fifth root. So we say x raised by 6 can be separated as x raised by 5 and times x. And the y, same thing, right? Then we still have fifth root x and y squared inside. Y squared. So this is simplified version. Right? So x raised by 6 split into x raised by 5. Power and index the same, so x comes out. Y split into 5 raised by 5, y raised by 5 plus 2. So y to the 5, then with the index 5, so y comes out. Then x, y squared stays inside the fifth root. 53. 53, we see, okay, 45 is 5 times 9. 36 is 4 times 9. So we can factor out square root of 9. And square root of 9 is just 3. Okay. Then we have x raised by, we can factor out x raised by 4. X raised by 4, square root, that's x squared. Then we still have inside, what's left? 5, right? Plus, well, 36 is, okay, 36, right? So 9 times 4, 4x left, right? Oh, this is not in the numerator. This is not in the exponent. So I have to write like this. Square root of 5 plus 4x, right? Because 45, x raised by 4, x raised by 4, x raised by 5. The common factor is x raised by 4. We factor out x raised by 4. Square root of x raised by 4 is x squared. Then 45 is 5 times 9. 36 is 4 times 9. So square root of 9. So 9 is a common factor. Square root of 9 is 3. So 3x squared comes out. What's left? 5 plus 4x left. Let's see 54. 54, oh, this is question 54 and this number 54. 54 equals 27 times 2. 27 is 3 cubed, so 3 comes out. Right. Then x raised by 10 can be split into x raised by 9 and x. So we still have a cubic root. So 3 comes out and x cubed comes out. And then what's left? 6 and x, right? Left inside the cubic sign. X. Let's see this one. We want to simplify this and the square root. Square root of 27. 27 is 9 times 3. So square root of 9 is a 3. Right? So either this one or this one. Right? So either this one, because this one has 3, this one has 3. Now let's see x term. So I have x raised by 19 and the square root, x raised by a and the square root. We can combine those two. That's x raised by 11. X raised by 11 can be split as x raised by 9 times x squared. X raised by 10 and times x. Then x5 comes out. So this is 3. 3x raised by 5. What's left? 27 divided by 9 is 3 left inside and the square root, and x raised by 11. So x raised by 10, 10 divided by 2 is 5, so x5 comes out, and we have 1x left, so it's a 3. 56, 81 is a 3 raised by 4, so we get 3 raised by 4. B to the 18th power can be split into b to the 16 times b squared. B to the 16 divided by 4 is 4, so 3b raised by 4. Then C has to stay inside. So the root index is 4. What's left is a b squared and a c squared left inside. Let's see this one, cubic. So -4 raised by 3 is -64. So we get -4. C to the 8th power can be split into C to the 6th power. So come out 6 squared, because 6 divided by 3 is 2. But then inside, so we still have C squared left. And for C term, for A term, A raised by 15. 15 divided by 3, that's A raised by 5. And inside, so still have a cubic root. And inside what's left? Numbers, no, nothing that left. And I have C squared left. And that's it. Let's see this one. So 3 is all by itself. So this is 3 that are front. Then we have both being cubic root. Right. So we see this 8 is 2 raised by 3. So then 2 comes out. So we see y term. We have y raised by 3, y raised by 13. So that's y raised by 16. Y raised by 16. So y raised by 15. That's divided by 3. That's y raised by 5. Then for x term, x raised by 15 divided by 3. That's x raised by 5. But then we still have something inside. So numbers, we don't have anything, but a y term, because the y to the 16, we still have square root of y under the cubic root. And the 3 times 6, 3 times 2, that's 6. So the answer is this, 6x to the 5th power, y to the 5th power, and cubic root of y. Let's see this one. 9 is a 3 squared. By 3 squared, then raised by 3, 2 times 3 is 6. So this just equals to 9. So x raised by 7 can be split into x raised by 6 times x. X raised by 6 divided by 6 divided by 2, that's x raised by 3. Then we still have 1x under the square root sign. So x raised by 3, square root of x. Oh, this we see the index. Index 10, index 3. We multiply those two index. So we get 3 times 10, that's 30. So index becomes 30. This one we can simplify. Right? 25 is 5 squared. This 25 is 5 squared. Is all under the index 4. We have 5 squared times 5 squared. That's 5 raised by 4. The index is 4 also, so we get 5. The denominator of 2, the a is 2 raised by 3. 2 times 2 raised by 3, that's 2 raised by 4. So that's 5 over 2. Simplify this one. So we see x raised by, so this one, let me write in the pencil. So when we need to calculate it, we write as rational exponent. X raised by 3 over 5. Right. So another one is x raised by, so same base, we add the exponents, 4 over 6. Well, 4 over 6 can be simplified as a 3 over 2, as a 2 over 3. Then we just combine 3 over 5 and 2 over 3. So that's x raised by, common denominator is 5 times 3, 15. Then we have 3 times 3 plus 2 times 5, which is 19. So a equals to 19 over 15. So that's 8. Let's see this one. 2 layers of exponents will multiply. So 6 times 14, 84. So a equals to x raised by 84 divided by 7 times 11, 77. $65. We want to simplify this. We need a like radicals. So square root of 18 can be written as a 3 radical 2b. Right? Because 18 is 2 times 9. The square root of 9 is a 3. Minus 200 is 100 times 2. Square root of 100 is 10. So that becomes 10 square root of 2b. Then 128 divided by 2 is a 64. 64 is a squared. So that becomes a square root of 2b. Now we have a common, we have left radicals, right? We have square root 2b, square root 2b, square root 2b, like radicals. Then 3 minus 10 plus 8. 3 minus 10, negative 7, plus 8, just 1. So this equals to square root 1 square root 2b. We don't need to write this 1 up front, it's just square root of 2b. Okay, I'm going to leave the rest for another time to do it.